Name of the God, the most gracious, the most merciful. Glory be to Allah and praise be to Him. Glory be to Allah the Great. We welcome you to our first lesson on the electric field. We welcome your opinions and suggestions. The first, we begin of mathematical laws and their applications in this lesson. There are three laws very important of this lesson. First, the magnitude of electric field as non-uniform or uniform. It's okay for two sorts. E equal Coulomb constant multiply magnitude of Q upon R square to calculate the amount of electric field at a point in non-uniform electric field. The next one, to calculate the amount of electric field at point in a uniform electric field and irregular is the same, equal F electric upon magnitude of Q. It's equal the magnitude of electric field. Number 3, to calculate the amount of electric field at the surface of the isolated and charged spherical conductor. E electric equal Coulomb constant multiply magnitude of Q upon R square capital, which mean the radial of the spherical conductor. First, the electric field. That's mean to calculate the amount of the electric field at the surface of the isolated and charged spherical conductor. The electric field intensity E vector, it's equal or it equals the magnitude of electric force acting on test electric charge placed on the point in the field. The electric field intensity is vector quantity, meaning it has both magnitude and direction. The unit of measurement of electric field strength is Newton per Coulomb. First, the electric field of a point charge. The electric field intensity of a point charge is calculated from the equation E equal Kc multiply magnitude Q upon R square. R means the distance between the point and the surface of the spherical charge. And from this equation we notice that the field intensity depends on, first, the electric field and the quantity of charge. The amount of a charge magnitude Q and the field are directly proportional to amount of a charge. That's mean E proportional of magnitude Q as shown in the law, as shown in the adjusted figure, which is on the left side, like this. On the perpendicular axis, we call it y axis, and the x-axis, which horizontal. We take E by Newton per Coulomb, and we take Q per just Coulomb. Notice that the proportional begin from the 0 point, and go on. Number 2, the distance between the point charge and the point of field effect and the field intensity is inversely proportional to the square of the distance, equal E inversely R square, as shown in the adjustment figure, or inversely with the reciprocal of R square, like this figure. This is the relationship between E and R. We can express it or show it with two ways, like proportional or inversely proportional. Here inversely proportional, and here proportional only. But here you have to notice that 1 upon R square, but here R square only. Number 3, the type of medium surrounding the charge Kc, which is a constant value and equals in the case of the air or vacuum. We consider air or vacuum the same. Kc equal 9 multiply 10 force 9 Newton meter square upon Coulomb square. Number 4, the field intensity doesn't depend on the type of electric charge. Rather, the type of a charge determines the direction of the field only, as appears on the figure. This is the figure. Notice that this is the positive charge Q. You have to know the direction come toward to left. Here in this point, the direction of the field. But here in this negative column or charge, the direction of E come toward from the first or last distance to the charge. Okay. Exercise 1. If the electric field intensity at point A is equal to 72 Newton per Coulomb, answer the following. First, find the distance of the point A from the electric charge, and what is the magnitude of the field at infinity. Okay, we have to see the figure. Here the negative charge, which is equal minus 2 nanocoulomb. Here the distance equal R. We have to know the direction of field. Here come to left. That means it's go to charge or negative charge we shown in the figure. Solution. We apply the relation for calculating the electric field, as we'll see. E equal Kc multiply magnitude Q upon R square leads to R root square. Kc multiply Q magnitude Q upon E equal 9 multiply 10 9 force 9 10 force 9 multiply 2 multiply 10 force 9 minus 9 upon 7.2. That mean leads to 0.5 meter, half meter. Number 2 or B, the E in infinity equal 0 because there is no field, no effect of the charge. Exercise 2. If the distance from point B is twice the distance from point A to the charge Q, this is the charge Q, it's negative. This is A and this is B. B distance equal to this double distance of A, or twice distance of A. Okay, we want to calculate the field at point B. This is the law. EA upon EB. We apply the relationship for calculating the field intensity at the point as follows. That's mean we divide EA upon EB like this. This is the law, and this is the law, the same, but here in distance B and distance A. Kc multiply magnitude Q upon R squared A, divide upon Kc multiply Q magnitude Q upon R square B leads to EA upon EB equal Kc multiply magnitude Q upon R square B multiply 1 upon Kc multiply R square B upon magnitude Q. Here Q deleted with Q, Kc deleted with Kc, just R square B and I and Q. Here R square B 4 and R square A 1, because this is 2 square equal 4 and here 1, and by the multiply the two middles with the two ends leads to this equation. EA multiply 1 equal EB multiply 4 leads to EA equal 4 EB. This is the relation between the two fields. The solution in a simple and faster way. Now we can make solution better and faster and simple like this. We don't write or put the constant the amount like Kc or like Q, because it is constant of these two equations. That means we deleted it in the two sides. EB upon EA equal R square A upon R square B leads EB upon EA equal 1 square upon R square. That's mean 1 on 4 equal EB multiply R equal B EA multiply 1. That's mean EA equal 4 EB. This is the faster way. Exercise 3. If the electric field strength at point B is point B, which is distance between the charge and B equal 25 centimeters, is equal 900 Newton per coulomb as shown in the figure. Calculate the electric field strength at A. The same way, we will make the same way in the last exercise. Here, apply the relation for calculating the field intensity at point as follows. EA upon EB. We explained that before. We deleted the constants Kc and Kc, Q and Q. That leads to 0.25 square upon 1.5 square. That's mean EA equal 2500 نيوتن على كولوم open column. Okay. Exercise 4. Based on the data shown in the figure. This is the figure. We have two charges. First one is minus equal minus 4 microcoulomb, and the next one is equal 1 microcoulomb. There is 2 charges. The charge 1 and the charge 2 has distance between them 20 centimeter, and the point B, distance between the charge, the positive charge, and the B is 10 centimeters. Here the direction of E1, because E1 is minus. The vector goes to or towards the Q1, and the E2 go out from positive charge. That means we will find the result subtractive two vectors from each other. Let's see. E1, we apply the law. We know it every time. When I apply the amount of the distance and the charge like this, then the result is 4 multiply 10 force 5 Newton per coulomb. It's direct to the right like this, which is one white vector. Next, E2 equal constant of column magnitude Q2 upon R squared 2. We apply every value of 1. That's mean 9 multiply 10 force 5 Newton per coulomb to the left. Summation E equal 9 multiply 10 force F minus 4 multiply 10 force 5. The result is 5 multiply 10 force 5 Newton per coulomb to the left. Completed. Thanks to God, and see you in the next lesson. We pray, send peace and bless our messenger Muhammad and upon his family and companions, all of them. To follow us, this is the link of our channel. You can go to it and follow up us.